Welcome to this tutorial presented by oraclecoach.com. This is Claire Rajan, and in this tutorial I'll explain the theory behind joining tables. The objectives are to understand when to join tables, to explain the different methods available in joining tables such as equijoins, Cartesian joins, non-equijoins, outer joins, and self-joins. I'll be discussing the traditional syntax that is used to join tables in Oracle, where we will write a join condition in the where clause of the select statement. On this slide, there are two tables and one output. The tables are the countries table and the regions table. The countries table has three columns: country ID, country name, and region ID. For the first row, where the country ID is AR, the name of the country is Argentina and its region ID is 2. Now consider the regions table. It has two columns, region ID and region name. If you look at the second row, where the region ID is 2 and the name of the region is Americas, there is a relationship between these two tables. A country belongs to a region. So looking at the two tables, the relationship is based on the region ID column. You can then conclude that the country with the name Argentina belongs to the region by the name Americas. The output that is shown below is the result of a query where we have retrieved the name of the regions and the name of the country. The region name is coming from the regions table. The country name is coming from the countries table. So this output is based on two tables. Joining data is done when you retrieve data from more than one table. In order to retrieve the region name and its country name, you needed to access two tables, the regions table and the countries table. You would then have had to perform a join between these two tables. This slide describes the different types of joins that are available in Oracle, such as Cartesian joins, equijoins, non-equijoin, outer join, and self-join. This slide also displays two types of syntaxes that can be used when writing join statements. The traditional syntax is Oracle proprietary and has been available in all versions of Oracle. The SQL 1999 compliant syntax is standardized syntax for writing join statements. In this tutorial, I'll be explaining the traditional syntax that always allows you to write the join condition that relates the two tables or two or more tables in the where clause. On this slide, we have the syntax that is used when writing join statements. In a join statement, you would list multiple table names in the from clause. I'm going to read the syntax so that you have an idea as to what I'm actually going to be speaking about. The select statement goes as select column, comma, table1 dot column from table1, comma, table2, where table1 dot column equals table2 dot column. Now this is a very general syntax that's not specifically identifying any tables. However, there are a number of different things that are of importance in this syntax. If you look at the from clause, we have two tables listed, one after another, separated by commas. If you look at the where clause relates the two tables based on a specific column. I have table1 dot column equal to table2 dot column. Also make a note that everything that is in square braces means it's optional. It's not necessary to prefix the table name before the column name. There is only one reason when prefixing the table name before the column name becomes mandatory. It's when the column name is the same in both the tables. The first type of join I'll be explaining is the equijoin. An equijoin is done when data in one table is related to another table based on the equality of values. If I take you back to the previous example that I discussed, Here we were looking at the two tables, countries and regions, and what we said was in order to retrieve the output, the region name and the country name, the two tables had to be related based on the region ID column that exists in both the tables, and the equality of the values between the two columns is what identifies which country belongs to which region. So this would be an example of an equijoin. The statement that you would have written in order to perform the equijoin is select region underscore name, comma, country underscore name from countries, comma, regions, where countries dot region ID is equal to regions dot region ID. We've listed the two table names in the from clause. In the where clause, we've identified how data from one table is related to the other table based on a condition of equality. In the select column list, you have identified the values that you want to see in the output. In the next example that we have on this slide, one more column is being retrieved. It is the region ID column. The region ID column exists in both the tables with the same name. When retrieving a column that has the same name in both the tables in the query, it becomes mandatory for you to prefix the table name before the column name. So remember to use a table prefix to qualify column names that appear in multiple tables. This avoids any type of ambiguity when writing the select statement. We now discuss what are called as table aliases. Table aliases are used to simplify queries, to improve readability and improve performance. An alias by definition is a substitute name. Here we are giving alternate names for the table names. If you notice the from clause, you have the name countries followed by a space and then the letter C. C is the table alias for the countries table. Sometimes it becomes easy for you to give short names for table names, especially if they are long. Similarly, you have the name regions followed by the letter R, and R is the table alias for regions. Observe the where clause. Earlier, we had a where clause written as where countries.region_id is equal to regions.region ID. Now, because you've created the aliases, instead of the original table names, you're making use of the aliases. And it is mandatory for you to use the alias once you have defined it in a select statement. To summarize, a table alias is a shortened name for a table that is defined in the from clause beside the table name separated by a blank space. The next type of join is known as the Cartesian join. The Cartesian join is performed when data is retrieved from multiple tables without writing the necessary join conditions. If you have a look at the select statement written on this slide, we have select country underscore name, comma, region underscore name from countries, comma, regions. The statement has been completed over there. There is no where clause which identifies how the countries table is related to the regions table. Now, let's assume that there are 25 rows in the countries table and there are 4 rows in the regions table. When a Cartesian join is performed, every single row of the first table is joined with every single row of the second table. So you'll get a cross product type of output, and the Cartesian join will return a total of 100 rows. The next type of join we look at is known as a non-equijoin. A non-equijoin is done when you relate data in tables based on a condition other than equality. Here we have 2 outputs. One is based on a table called SalGrade. The data in the SalGrade table identifies the grade that would be assigned to an employee based on their salaries. The table has got 3 columns: grade, min-sal and max-sal. Min-sal stands for minimum salary, max-sal stands for maximum salary. The grade is a character value which could be A, B, C or D. Now if you try to understand the data, the grade A is assigned to a person who earns a salary between the minimum salary of 1 and the maximum salary of 10,000. The grade B will be given to anyone whose salary is between 10,001 and 20,000. The grade C is assigned to anyone who earns a salary between 20,001 and 30,000, and D is assigned to a person who earns a salary between 30,001 and 40,000. The other output on this slide is the result of a query that is being performed on the employees table. The first name, job ID, and salary are being retrieved. The salary of the first employee in the output is 24,000. If you had to identify the grade of the employee, it would be decided based on the salary. The salary is 24,000 and lies within the range where the minimum salary is 20,001 and 30,000, and therefore we can say that the grade of this employee, whose name is Stephen, is C. Here we have the query that would have been you would have had to write if you were performing the non-equi-join to display the first name of the employee and the grade that the employee belongs to. The query is select first underscore name, comma grade from employees, comma sal grade, where employees dot salary between min sal and max sal. Notice that there is a relationship between these two tables, but it's not based on a condition of equality. It's based on a condition where you're using the between and operator, and that's why it becomes a non-equi-join.